MS Ramaya University of Applied Sciences.
Hello friends, with this experiment we are determining the particle size distribution and fineness modulus of the coarse aggregate and the fine aggregate. Apparatus: IS sieve of size 75 mm, 40 mm, 20 mm, 10 mm, 4.75 mm, 2.36 mm, 1.18 mm, 600 micron, 300 micron, 150 micron, balance and sieve shaker. Fine aggregate is the sand used in mortars. Coarse aggregate is the broken stone or gravel. Mixed aggregate is the combination of coarse and fine aggregates and are used in concrete. The coarse aggregate, unless mixed with fine aggregate, does not produce good quality concrete for construction works. The size of the fine aggregate is limited to maximum of 4.75 mm gauge, beyond which it is known as coarse aggregate. Fineness modulus is only a numerical index of fineness, giving some idea of the mean size of particles in the entire body of aggregates. Determination of fineness modulus may be considered as a method of standardization of the grading of the aggregates. It is obtained by sieving a known mass of given aggregate on a set of standard sieves and by adding the cumulative percentages of mass of material retained on all the sieves and dividing the total percentage by 100. Procedure: Coarse aggregate. Take 2 kg of coarse aggregate of nominal size 20 mm from a sample of 10 kg by quartering. Carry out sieving by hand. Shake each sieve in order: 25 mm, 20 mm, 16 mm, 12.5 mm, 10 mm, 4.75 mm over a clean, dry tray for a period of 2 minutes. The shaking is done with a varied motion, backwards and forwards, left to right, circular clockwise and anti-clockwise, and with frequent jarring, so that the material is kept moving over the sieve surface in frequently changing directions. Find the mass of aggregate retained on each sieve taken in order. Fine aggregate. Take 2 kg of sand from a laboratory sample of 10 kg by quartering and break clay lumps, if any, in a clean dry pan. Arrange the sieves in order of IS sieve numbers 4.75 mm, 2.36 mm, 1.18 mm, 0.6 mm, 0.3 mm, 0.15 mm, keeping sieve numbers 4.75 mm at the top and 0.15 mm at the bottom. Fix them in the sieve shaking machine with the pan at the bottom and cover at the top. Keep sand in the top sieve. Carry out the sieving in the set of sieves as arranged before for not less than 5 minutes. Find mass retained on each sieve. Fineness modulus is an empirical factor which is obtained by dividing the sum of the cumulative percentages of aggregate retained on each Indian standard sieve taken in order by 100. Data collection and tabulation is as shown in the table. Data collection and tabulation is as shown in the table. Fineness modulus is then calculated.
Hi students, now we are conducting an experiment on fineness modulus of fine aggregates. So the apparatus required for this is, for conducting this experiment we want standard IS set of sieves 4.75 mm, 2.36 mm, 1.18 mm, 600, 300, 150 and we want a pan. So along with that there is a lid cap. We want the fine aggregate to be tested. we want a wave balance. Let's start the experiment. I am going to take up the known quantity of fine aggregate. You may take up with 500 grams or you may go on with 1 kg. I will be taking 1 kg of fine aggregate. I taken 1 kg of fine aggregate. I am going to place this on the standard ISCU set. I am going to sieve it manually or using the sieve shaker for 10 minutes. After seeing it for 10 minutes, I am going to open the lid. I am going to take up the weight retained on each set of sieves. So there are a few particles left out on this. I am going to measure the weight. Note down this particular weight. Next, 2.36 mm sieve. I will note down the weight. 1.18. I will note down the weight. 600 microns. I will note down the weight. 150 microns. Note down the weight. And I'll also note down the weight of particle which is retained on the pan. Using all this weight, your percentage weight retained as well as the percentage passing will be calculated. You are going to plot the graph of percentage passing versus sieve size. Okay, using that particular graph, the fineness modulus is calculated. So here you can calculate D10, D30 of sand, D60 of sand. That is what we call as a coefficient of uniformity, coefficient of curvature. Okay, and also this test is very helpful because we need to know the zone of sand. Either it's a zone 1 sand, zone 2 sand, or 3 or 4 zone sands. So we need to classify this depending upon the percentage passing what we are going to get. We will compare that with the standard IS 383 readings and we are going to tell what zone of sand it belongs to. So we just did it for fine aggregate. The same way we are going to do it for the coarse aggregates, and the fineness modulus of fine aggregate as well as the coarse aggregate will be determined. This completes the fineness modulus of aggregates.
At MSR UAS, we spark your imagination unlike any other.